Is it my turn?
All right, let's do it.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 142. Today we're talking about 65 days of airtime, race cars staring at the ceiling, a pushy white cane, and soapy water rockets. We have announced another keynote talk at Remoticon, Elliot. It is Alicia White, embedded engineer extraordinaire.
How many keynote talks are we having?
We are having 3, so this means that they have all been announced now. I'm especially looking forward to Alicia's talk because she's diving into a dark subject of embedded, which is RAM usage, and especially that map file that the compiler spits out that you never look in.
Yeah, I love this one. Alicia's a super friend of Hackaday. She's judged for us before. She is an embedded genius and will be sharing her hard-earned knowledge in this talk. I think that's awesome. I just love that it's going to be a super techie talk, and it's a super techie talk that's like right up my alley.
Oh, yeah, and I like the kind of like collection of keynotes that we have now. So we have, Keith Thorne is doing a talk on LIGO, which is the installation that's searching for gravitational waves, so like heavy science. And then Jeremy Fielding is doing a talk on mechanical engineering, making stuff move, which I think is a place that a lot of us working with, electronics and software want to be better at that, but it's kind of, it feels like it's a different room, like a different workshop to be in. And so I think that'll be really enlightening. And then just a high-end embedded thing, like something where we can all learn a little bit from it. I know that oftentimes I'm wondering, like, how do I know? Okay, I've compiled my firmware. I want to know, like, am I going to have problems? Like, am I going to have heap and stack problems? If I run out of RAM, like how are things arranged? Am I wasting RAM because I have things that should be constants and should be in flash that aren't in there? And like, how do I know that? And so she's going to give us a lot of hard-fought experience that shows how to look at that. And then I believe give us a guided tour of, like I said, those map files and what you can use them for.
I love her metaphor for this with like Ramlandia or whatever it is. I saw that and I started reading some of the country names, and that's absolutely hilarious. I think that's pretty funny and pretty creative.
So, of course, Remoticon is coming up in just 3 weeks from today, actually, Elliot. Who's panicked? Not me, definitely not. November 19th and 20th, we have 16 accepted talks and 3 keynotes. So we've announced almost all of those talks. Yesterday, we had another talk announcement with, I think, 4 more people, and there'll be one next week with 3 more, but we're getting super excited. What else do we need to know about it? There's going to be, should I say it out loud, Elliot, a game show?
Sure.
We've been beating around the bush on this one. We're going to beat around the bush for probably another, maybe Monday we're supposed to announce this. I better get right on that after this podcast. So, but it's going to be fully interactive and super fun on Friday night. Saturday, of course, Hackaday prize ceremony and a party to close things out. So if you are interested in this, I guess remoticon.io is where the site will end up, but it's not fully up yet. So I think another week for that. For now, you can hit up hackaday.com and find Remoticon posts there or in the show notes.
This is a journey into sound.
What's that sound?
What's that sound?
What was that sound?
Da-da-da-da-da. Can you remember what that sound was, Mike?
I thought it was a music box.
Do you want to hear the rest of that one real quick?
Yeah, show me. Well, if you'd played that part, it would have been a lot easier.
Damn, Skippy. That's why I cut that part out, because it was just too obvious.
Well, we had a number of people get it this week. I think there were 24.
Yeah, so this is one of the various number station recordings. These were Cold War up to the late 90s secret shortwave stations that would play out crazy random numbers and were probably either communications to spies or things that wanted to look like they were secret communications spies. I don't think we actually know the truth on this. Anyway, these are recordings made by the CoNet project, and this was one of the number stations that opened up with this little music box track playing the Swedish Rhapsody, and so that's the nickname that the numbers station got. But surprising number of people got it right. The best wrong answer is that it's a hacked Link NYC Wi-Fi kiosk pretending to be an ice cream truck. And we have 24 correct answers, so I would like to pick one out. And in honor of the spoken word number stations, I am creating a random number in Bash, feeding it to a speech synthesizer, and playing it for you all right now. See if this works.
20.
And the winner is number 20. That would be Bobbert. Congratulations, the Swedish Rhapsody number station.
Woohoo! All right, we will have a t-shirt headed your way for being the correct answer this week.
And tune in next week. We'll have another secret sound file for you to guess.
That brings us to our hacks. What do you have on your list, Elliot?
I'd like to start off this week with one that is a lot more in-depth than I think I gave it credit for at the beginning. I started off reading Andy's Fast Indoor Robot Watches Ceiling Lights Instead of the Road. And I thought, well, this is a pretty clever autonomous indoor vehicle driving hack. The idea is the camera is, instead of pointing forward at the racetrack that he's trying to drive around, or instead of looking at the orange cones that it's supposed to avoid as it goes around this racetrack, it points basically straight up at the ceiling, and so it can see the overhead lights and use those to figure out how far it's gone and in what direction it's gone. Learn the track that way just by watching overhead, and then just rip through it at the fastest speed it possibly can. It's a super clever strategy, and I really like it. It uses a really wide angle fisheye lens, so it gets a big portrait of the roof and actually a little bit of what's going on ahead, which Andy uses to great effect by unwarping the fisheye lens of the road ahead of the little car and showing us that video as well. This is great because if you think about one of these little cars, it's 10 centimeters off the ground. It doesn't have that much of an angle on things to see things, right? Like it could see the road ahead of it. It can't really see that much of the scene to figure out where it's going, where it needs to go. Whereas if you look straight up, there's nothing impeding its view of a wide stretch of the ceiling. So it's just got a lot more nice fixed reference points.
Well, and it's not a new idea. It's an idea that's been seized on before. I am familiar with it from robot vacuum cleaners.
Oh, we've got one of those.
I think it's some type of either depth camera or like LiDAR, but it does edge detection on the corners where the ceiling meets the walls in your room. And just like you were mentioning with the RC car being, 10 centimeters off the ground, if you're this tiny vacuum cleaner and you're dwarfed by office chairs and dressers and that sort of thing, being able to see the really simple shape of the room above you really helps. And in this case, since it's using a camera, having this grid, so if you think of we call them suspended ceilings. I'm not sure if they're called the same thing everywhere else, but it's a grid system that then has tiles in it, and then some of the tiles are replaced with light fixtures. And so these light fixtures are on a pretty precision grid, and then add to that since they're a light source, they have great contrast against the background. If you're doing optical camera sensing for this could potentially be better than doing that corner detection that I was talking about with vacuums.
Yeah, we actually have a vacuum like that. Our Roomba it's one of these Panasonic ones that's got an upward-facing camera. I don't really know how it works, but I think it does what you're suggesting. I think it does edge detection on the square on the ceiling, which is pretty clever. It hits things just about as often as the Roomba does, though.
Well, it's still going to hit stuff, but at least it knows that it needs to get to different parts of the room. So it forms the map that way.
Yeah, exactly.
And then it has to do other stuff to find the obstacles. Yeah, and I think that's the same thing for this car, right? This car finds kind of precise location, but then, to know where the track is, it has to have other cues.
And this made me think of some stuff we've covered before, like space probes that go far away from the Earth. When they need to orient themselves, they actually look at the stars to figure out where they are and get their bearings.
Ah, right.
Maya Posh wrote up a neat article on this a while back, Star Trackers. I'll put a link in. And so this is kind of the same problem in a way, except here the car has to be going really fast. And that's where this gets kind of interesting, is that all of this processing has to be done in super fast real time. And Andy's tricks to make that all work, my guess is he gets into about half of them in this post, because he does mention that he has some more still in the code, and you should go dig through it if you're interested in the time optimizations. The basic routine here is that it looks up at these lights and it does kind of a point-wise undistortion using the OpenCV's kind of unfisheye lensing algorithms. And then it can figure out the different angles to all of the brightest light sources from where it is. And then it uses these and the last point it was at to figure out in what direction it's pointing and then how far it's gone. And this is actually really clever because it does know where it just was. So it can use where it just was as a guess for where it is now and then figure out, how far it's traveled from that. So it's not like it's, navigating from scratch every time. It's navigating from the last image it took, and it just kind of chains these together and runs the course. It goes exceptionally fast. It's really nice to see this thing working. The math to do this is fairly complicated.
Crazy.
If you've done any 3D graphics programming, it's kind of similar and you won't be totally lost, but it is not easy either. At one point, he ends up with this, 3x3 X, Y, and heading, 3x3 matrix that he needs to invert. And I thought the funniest thing is he says, I guess I could solve it numerically, but instead I'll try to invert this matrix. And I don't know, inverting a matrix by hand, like writing out the formula, is one of those things you have to do in college, I think I remember.
This set that he's got with all of these summation signs in it, displaying that in latex is harder for me. I think that's hard enough for me. Actually doing the math here is a little bit above my level.
I can vaguely remember how to do this sort of thing, but what's interesting here is that he does it instead with SymPy, which is a symbolic computation library for Python. And I thought that was fun that he inverts a 3x3 matrix using SymPy. Kids these days. But then also that he walks through a tiny little bit about how to simplify this inverted matrix and chunk it into a bunch of pre-computable parts so that, if you compute the sine of the various angles first and you pre-compute some of the other things that go into this matrix, you can actually just run the calculation super fast, which lets this car steam around the track. He gets to the point in the end where he says, look, the navigation is a solved problem now. Now it's a problem of figuring out what the optimal path for my robot is when it already knows the map. So kudos to Andy, and thanks a lot for writing this up in so much detail.
All right, imagine it, Elliot. There is an obelisk. It appears. It's polished silvery metal. And you walk up to it and you pull out your brass key. And you put the brass key into a slot that wasn't there before, and you unlock the new dimension.
Spacey.
That is the gist behind this amazing hack that Andrew Klein pulled off, but it's not an obelisk. It's actually a very large bolt or screw, and the screw just has a very flat, shiny head to it, unless you pull out the special screwdriver made of brass so that it doesn't mar this shiny surface. The screwdriver also has in it 3 magnets, and when you press it into the screw head, a invisible or previously hidden set of slots appear, I'm assuming spring-loaded. The thing here is Andrew's trying to figure out that he built it, it actually exists. He's trying to figure out if he wants to try and produce it and sell it. And it's a beautiful piece of machining. I think that there's no other explanation for how the hidden slots work than EDM, which is electrical discharge machining, which we've seen used before. If you've ever seen like a big block of aluminum with like a star shape that slides into it, and once the two surfaces are even, it completely disappears, that's done with EDM.
He says this in the video, and I've seen these little toys myself. When the EDM manufacturers want to show you, with what incredible precision they can make these things, they always have these like toys that they bring to the exhibitions where it's like it slides in so slowly that even though it's a huge chunk of stainless steel, it goes slowly in and then completely disappears because there's no lines. It is the most incredible demonstration of engineering tolerance, and I share with Andrew the feeling that is nearly magic and something cool ought to be done with it.
So the magic part, I think if you're going to have one of those desks that has like hidden compartments where you have to like press things to open up drawers, like that is the killer thing here. I've seen maybe like ancient locks where you slide different things to open where the keyholes are, and then it opens a door where a different key comes out. And I think this could definitely be part of that. Some people in the comments were asking like, well, what's the point when you could just have a disc that covers the hole that your regular screw is in? And I think that there's definitely that holds some weight to that argument. But the mechanism itself, I mean, you would assume there's got to be a spring mechanism in there, right? I would just like to see how he built it because I want to know how the spring went in. I assume somehow the threaded part of this is very fat. I mean, it's fatter than your thumb. So I assume that the threaded part of this bolt is hollow, and then from the underside, the like EDM'd part that hides the slots for the screwdriver goes in there first, and it has a T shape so that it has a solid stop, and then a spring goes in there, and then it's probably the hollow part of the threaded bolt on the inside is also threaded, so then there's like a screw that you put in there to lock that all together.
Yeah, totally. Yeah, because the obvious screws have to be added on second, because otherwise there's no way to get the springs in on the other side of the stoppy central part.
But honestly, as far as this is concerned, people talk about how the lock on your front door isn't really that secure. Like there's bump locks and, people with lock picks and stuff. Like this could be as equally secure as like a crappy front door lock.
Just by nobody being able to figure out what it is.
Right, yeah, exactly. Although I suppose, he shows with just like a thin brass rod that's, 3 millimeters in diameter. He pushes that little part in. So you could do that and then like use some needle nose pliers to turn it. But it does seem like a whimsical, like you said, magical. This could be a Harry Potter, wizard's doorknob.
My next hack is a video by The Q building a water rocket that lands via parachute. And this is a nice water rocket build video. It's one of these videos where the person just kind of makes it and takes a lot of care in making the video of them making it. So the video itself is kind of fun and attractive. It basically consists of him taking a bunch of Coke bottles, drilling out some bolts to use to screw them together. The bolts are drilled out so that the pressurized air that will later make this rocket ascend into the air by pushing water out has some space to go up from one kind of Coke stage up to the next. At the top, it's got a cardboard parachute holder and a little flippy open door. The door is on a little mechanical timer, and it lets the parachute out. So the idea is you set the timer, and then you go, and the parachute unloads in 2 seconds, hopefully when the rocket is at apogee and it parachutes back down. The one little bit here that's a little bit of a fun trick, I guess, is that the bottom stage of the rocket has pressurized water in it, and then the top 3 or 4 Coke bottles on top of that make up a second pressurized vessel, and they have water in them, and there's a little aluminum tube that sprays out to the bottom. So what happens is the lowermost Coke bottle vents out first, and then the second one vents out slower after that. So you kind of get a 2-stage rocket. It kind of goes poof and then fizz as it keeps going up into the air. I got super into water rockets a couple years ago, and I want to talk about a lot of the details of this rocket in a sec. But what'd you think? Have you seen these before?
I have not seen the multiple stages like this, so I thought that was really special. I liked the launch mechanism for this. There's just a U-bolt that happens to be the right width to kind of lock onto the collar of the 2-liter soda bottle. And so you can tie a rope to the U part of it and you go off to the side and yank that. So it's a nice little easy to build launch platform. What I was interested in, Elliot, is at some point he mentions putting like some dish soap in with the water as the propellant, but I don't understand what that's there for.
That's actually a really cool trick. I super nerded out on water rockets about 2 summers ago. And so I've seen all of these tricks before. And I can tell you some of them come with upsides and some come with downsides. That one with adding soap in there, it generates foam. And so it kicks out not just the water, but because some of the air is entrapped in the foam, it kicks out some of the air too. So basically it's just throwing more stuff out of the rocket and that gives you more thrust. If you want to see this experiment done right and measured quantitatively, you should go to Air Command Rockets. And this is a guy in Australia who has, as far as I know, the highest water rocket launch on record right now. And it's something like 3,000 feet in this like handmade carbon fiber wrapped insane 1,000 PSI water rocket. The thing is an absolute nightmare engineering marvel. But he experimented around with adding soap to the water just to make it foamier so that it can kind of push a little more mass out. And that turns out to get you kind of 10% more thrust on your water rocket, which is kind of fun. The particular way the parachute comes out of this is an innovation by US water rockets. I'll throw a link to their stuff in there. And they came up with this idea because as long as you're screwing bottles together, you kind of have this extra space where the neck necks in before it meets up to the other bottle. And the idea there was just, well, that's a great place to cram the parachute. The idea for using a toy timer is really old. I think it's been attributed to Bruce Berggren, but I've seen it done on some lot of German water rocket websites. I'll throw some of those links in here, particular waterrocket.uh lab. The part that I'll quibble with here is that little U pulling mechanism.
Ooh, you don't like that one.
And I'll tell you why. There's a lot of pressure pushing that rocket up into that U, and it makes a lot of friction on it. And actually, if you watch his video, you can see that he almost pulls the base of the water rocket stand over as he's pulling it because it's hard to release. And as you go to higher and higher pressures, there's more and more force holding that yoke in place. And it's more and more likely that the thing is going to tip over at you and hit somebody. And one of these water rockets put up to 100 PSI. I mean, if the thing's going to go 400 feet in the air, you don't want to get that in your face. So, sketchy. The best release I've seen is the Clark zip tie release. I'll throw a link for that in here. It's really clever. It's got a bunch of zip ties and it uses the fat part of them to grip around the little flange at the end of the bottle. And then you put a PVC collar up around it so it holds them tight against it. Then you just pull the collar down, it slides, and then the zip ties release on their own. I made some of these. They're awesome. It's extraordinarily low friction up to really high pressures. You should definitely, it takes like half an hour to like duct tape some zip ties and cut a piece of PVC pipe. You should definitely make one of those. And last but not least, if you're going to get serious about this and make one of these multi-stage rockets, you absolutely must pressure test it. And I'll throw in a good video about how to do that here. But the short version of the story is you might naively think, I'm just going to pump it up with air and see how hard it goes. But pressurized air holds a lot of potential energy. And when the thing breaks, you've got extraordinarily dangerous plastic shrapnel coming at you. Instead, what you want to do is you want to do a hydraulic test. You fill it with as much water as you can so that there's not much compressed air in there. The vessel still sees the same pressure, it's just all in the water. You still probably want to do it behind something, but I've busted a bunch of water rockets at kind of in excess of 130 PSI just to test them, just to see how far they'll go. And yeah, it's a little bit scary, but it's definitely nobody's going to get hurt as long as it's filled with water. So I'll throw in a video on that so that you can do it the safe way if you get into water rockets. And sorry, it's Northern Hemisphere winter coming up. It's a lousy time to be outside getting wet, but do your research now and you'll have some good water rocket projects coming up in the summer.
Well, if you do need a project indoors to keep you occupied over the winter, you might want to take a look at this next one. DIY King put together a e-bike build based on an alternator motor from, I'm going to say automotive, but I didn't actually look that up. I think it is a car alternator.
It's got to be a car.
It's one of those funny things, we've seen washing machine motors used as generators.
Sure.
So you kind of have this like using things backwards, right? So the alternator is supposed to create the electricity to recharge your battery from the spinning of the engine. In this case, you're going to put electricity into it, and it's going to be a cheap source of a good little motor. You can head down to the junkyard and get one of these for a song. It's difficult to build an e-bike that lets you continue pedaling. And so this is more like an entry-level hack because it completely does away with the chain and drives the rear wheel directly. You're going to get to do a little of your own welding, putting a plate on to mount this thing. And then also there's a fun amount of deconstruction because the gears are being reused from a motorbike that has been scrapped. So while you're at the junkyard, look for a moped. At the same time, what really caught my eye on this one, Elliot, is the battery. Did you see the making of the battery pack?
No, what happened?
Oh my gosh, it's a little crazy. So it is 4 lithium cells go into each pack. There's 12 packs put in series to make a battery, and then there's 2 batteries. And all together, when you have those 2 batteries in parallel, it's a 1,500 watt hour battery.
Oh my God.
I was like I went to Trek is in Wisconsin, so that's who comes to mind when I think about e-bikes. So I went to Trek's website, and their entry-level e-bike, which is like $1,600, has a 309 watt-hour battery. This one's 1,500. So
Sure.
It's a big battery. I did kind of scratch my head when I saw that the enclosure for the battery is MDF.
Okay.
That seems like a bad choice because I think that battery is going to have temperature issues in there. But then again, I thought to myself, if you have a runaway thermal event, does it matter what this 1,500 watt hour battery is housed in?
Yeah, it doesn't matter if you put it in thin sheet metal. It's as good as MDF. I think that's yeah, I guess you don't want them to get, they're LiPo cells. They're not hard battery cells. They're not like 18650s. They're LiPo cells. So you really have to be careful about like not puncturing them and not like physically damaging them and stuff. So
right, if you fall over
they've
on
got
the
to be
bike,
in something, right?
yeah, I would be watching out for them slamming into the side and accidentally popping open or something. But hey, maybe in the future we'll see solid state batteries that can boast these type of energy density. But that's just kind of bonkers. Other things I saw on this. A handlebar throttle that has a screen on it, I'm assuming to tell you battery voltage or remaining life or something like that. I thought that was cool, and I'm like, where do you get those? So I went to AliExpress. You can find those super cheap, like $2 to $12 for a bunch of different handles on that. So if you're looking to build one of these. And the last is I just watched a This Old Tony video from a couple of years ago on involute gears. So I was like thinking about that when I saw these 2 gears that they got from different places that they put together for this. And if you're wondering how you know whether or not your gear teeth are going to work in your system, I will put the link to This Old Tony in the show notes.
All right, my next hack is a video from 0033MER or 33mer. I don't know.
33mer. Mm-hmm.
It's a video from an awesome YouTube channel. This one is Simple Electronic Hacks Inspired Doing More with Less. It's a collection of kind of 15-ish analog electronics hacks that are dead simple. They're the kind of stuff you might have seen in like the old Forrest Mims electronics notebooks or something. He's got a blinking LED, one of the ones that has the built-in blinker, driving a lot of different things instead of like using a 555 timer. So he's got it flipping a relay or making a buzzer buzz. He's got some really clever circuits built around op amps. There's one that's a differential diode temperature sensor It's got a diode going into the positive side of the op amp and another diode going into the negative side. When you touch the diodes going into the negative side, the difference in the diode voltage changes with temperature. So when you touch one of them with your hand, it gets a little bit hotter and the op amp flips a switch for you. That's really cute. He does the same thing with LEDs, using them as little photovoltaic cells. There is, lifting the ground on a 7805 voltage regulator to get a bunch of different voltages out of it. Optos as level shifters. Just kind of this clever, simple, hacky, low-level electronics stuff.
Yeah, I love that. And it's always so nice to have a list of these hanging out around. I know we've talked a bunch about Leo Fernecki's giving tips on this, and I think this is another one to kind of put in your when in need folder. This is a place to find those hints.
And the kind of randomness combined with the cleverness of these reminded me of a book series, and I've actually got volume 2 of it on my floor right now. It's the Encyclopedia of Electronic Circuits, and if you haven't seen this series of books, you should go check it out. They're actually basically all scanned in on archive.org. I'll put a link for you in the show notes. This is a book series by Rudolf Graf, and so many extra circuits were contributed by William Sheets. He got added on as second author in version 3 or version 4. These are 1,000-page books, and they're all of these clever little circuits collected from places like, EDN or Circuit Cellar, or these old magazines that used to specialize in clever electronic circuits back in the day. And they are just so random and so enchanting that you actually have to check one of these out. It's got everything from touch sensors. I open to a random page and I've got audio squelch circuit, precise audio clipper. I open to another random page, infrared transmitter. I open to another random page, capacitance multiplier, JFET as coupled integrator. It's just an assortment of 1,000 random circuits that are interesting to the author, all put together in a book. And I think there are 6 or 7 volumes of this, and you can get most of them online. You really should get a printed out copy and just leave it around, because it's fun to just page through. All the circuits are explained, and so you can learn something about how the circuits work at the same time. I don't know how useful these are. With this video, you have to need the particular trick to find it useful.
Right.
And because it's so kind of random, I don't know how you'd approach it thinking, I really need an audio squelch circuit. Maybe I'll check out the Encyclopedia of Electronic Circuits. For that, they're super fun books just to have around and just to browse through when you're bored for a few minutes. And maybe the ideas will kick around in your head. And this YouTube channel is kind of a little bit like that, and you should absolutely check it out. His other videos are much more focused. They're things like, a whole video on Hall effect sensors or MEMS microphones. And he's using a whole slew of different microcontrollers and different programming languages, from the obscure Forth on the parallax chips to the mainstream MicroPython on the new Raspberry Picos. So definitely go give this guy's channel a look, even if you're not into the totally random, but watch the random too, and store them in the back of your subconscious.
This next one is an interesting proof of concept that comes out of a research group at Stanford University. And Elliot, I think both of us were kind of taken by one particular aspect of it. They're looking into making it easier to navigate around the world for people that are visually impaired, specifically people that use the white cane. And in this case, they've built onto it a Raspberry Pi 4 and a spinning LiDAR device so that it can look and see where the obstacles might be, and then through some processing figure that out and do some path planning. But that cool part that both you and I cued in on is there is a motorized omniwheel at the bottom, at the tip of the cane. And that omniwheel, a normal path planning, allows the cane to seek back and forth. But then when there's an obstacle, it will go a little bit more to one side to indicate to the user that the system has seen something and wants to, navigate around it.
I agree with you. That's what makes this such a cute project, is that most of the time that omniwheel is just freewheeling. When the cane system detects something ahead of you, it can kind of just nudge a little bit to one way. And that kind of tactile feedback is at once kind of unobtrusive to everyone around you. Like you're not drawing attention to yourself by getting this sort of feedback. It's not a digital voice screaming, hey, go left or something like that, right? It's a gentle nudge. But it's also kind of very, I don't know, human somehow.
Well, it's haptic, right? I mean, if it's going to pull the cane to one side, we call it haptic. And I'm always kind of skeptical because I associate like the vibration motor in your phone as the most common haptic feedback. And I'm just always disappointed that like with each new generation of smartphone or of the software running on it, that it doesn't kind of up the ante on what those vibrations mean. So there's obviously some limitation there. Either people can't learn it or the technology physically can't, convey more meaning. But like here's a completely new type of haptic thing that I think could have a big impact. So for instance, I think it's unlikely that we're going to have spinning LiDAR and a very powerful embedded Linux machine on every white cane out there. But for instance, I've been in the hospital system here in town, and it's this like giant mega building. And if you need to go somewhere, they'll be like, okay, follow the green line, because they have, 7 different colored lines painted on the floor and to get to a different department. Well, how do you follow that green line if you're visually impaired? But what you might be able to do is get something like this that has the wheel on it that can help you navigate. It will pull you through your different turns so that you can find the area that you're going to.
Oh, that'd be super cool. Yeah, and we got a couple comments that were, all about, hey, why don't you get blind people's feedback on this? And, you're just trying to solve problems for other people. And one of the guys on the team is blind, and he's doing the testing here. And then they also did testing on a set of sighted people and a set of blind people. And all of them walked around faster while using the cane, which I thought was a pretty interesting validation that it was useful. But also the normally sighted people who were blindfolded for this, for them it was a lot better, which I thought was also interesting because it shows that blind people get around pretty darn well with normal white canes and they're used to it. So for them, adding the extra nudge is a smaller benefit than it is for, blindfolded sighted people, because they don't know what they're doing with a cane. But still, it was useful even for the blind people, where useful was measured in increase in average walking speed. So I kind of like that.
We've seen a ton of different projects that kind of take on technology for the visually impaired. I wanted to add to the show notes one of them that's the digital white cane project over on Hackaday.io, that it has, we see these using like time of flight sensors or oftentimes ultrasonic. And so a lot of these have that, like they'll give you a vibration motor that tells you like, hey, something's entered the proximity or whatever. And I think it's interesting to look at those and see where those are and compare it to this one. And then also I'm going to throw in another link that is just going to the visually impaired tag over on Hackaday.io, because I do think those projects are interesting to look at. I'm pretty sure I've seen a lot more on there, and I think they're just not tagged. So you might want to search around yourself as well.
My first quick hack this week is a video by Teaching Tech. He reviews Super Slicer, another 3D printing slicer program. This is based on the same line of code that Slicer and then Prusa Slicer are built on, and it adds some extra features. Super Slicer, go check it out and check out Teaching Tech's review of it. The surf sensor adds depth to finding the ultimate wave. This is a great project by Foo Barbecue. It puts a $300 water sonar sensor and a Raspberry Pi, waterproofs them, and embeds them in a surfboard. The idea is that you can tell how deep the water is under your surfboard and maybe learn something about the waves from that. The jury's out on whether this is a useful thing or not, but it certainly is a fun excuse to play around with a sonar unit, right?
Right.
And last but not least, the humble NE2 neon lamp has a new trick. This is the culmination of some research by Johan Carlson into using neon lamps as microphones. Because they have a plasma, if the plasma wiggles, it lets more or less current through it. It's hard to get air sound waves to pass through the glass case and the neon that's on the inside. But if you strap them to something physical, you can use them as a mechanical vibration sensor like you would a piezo transducer or something, except they last a lot longer in rough environments because they're embedded in glass. And what I learned from this is that one of the warning signs for metal strain is that it emits 200 kilohertz audio signals, and that you could pick these up with a 2-cent NE2 neon lamp bulb.
First up on my list of quick hacks, we have an excellent little clock design that Mike Rankin put together. There's a ton built into this. It's based on an ESP32, and it's got a bunch of sensors. It actually can do weather. It's a weather display, which I think was the guiding principle that he started with it. But for me, I love the banner image on this one. You're going to see a really clear with great color LCD screen. It's showing 7 segment displays, and it's using kind of like a gray color to show the segments that are off. And I love that effect on LCDs. It's something to keep in mind when building your own projects. Up next, I'm really skeptical about this one, but I loved seeing it. I think you should see it too. It is a bed leveling tool for a 3D printer, and it's a standalone tool. So it's just a little like stick of gum sized PCB with a coin cell on one end and a tactile button on the other, and it has an LED. And so you put it face down on your bed, you manually move the head of the printer over to it, and you go down in the Z-axis until it presses the button just enough to get the LED to come on, and then you call that level. I don't know. It seems crazy, but it's worth a look. And finally, mesmerizing mechanical 7-segment display. I'm often thinking about like Japanese wood joinery and how cool those joints are. This is like that times 10,000. So they've taken all of the mechanics that would go inside of a 7-segment display in order to make the segments operate in order, counting up for the numbers without any kind of electronics or anything. It's all gearing, cogs, and everything else, but it's made of wood, and the look of it is incredible. The segments themselves are like a darker shade than the rest of the wood around them, and I think it'll make your weekend. So go look at it. It's time for our can't miss articles of the week. This is long form content written by excellent Hackaday authors. And Elliot, you're up. What's your pick this week?
This week, the excellent Hackaday author I'm picking is me, because I've had something stuck in my brain and I need to get it out. Last week, we talked about X-Dolly clock, and I mentioned that, Mike should go look at this code because it's got to be well written because it's written by Jamie Zawinski. And then I went and looked at the code myself. And one of the things that's lovely about this code base is Jamie's comments in here. They include not just comments about what the functions do, but about why he wrote them in particular ways and what you should tweak if you're tweaking things. So some of them say, this was just here for optimization purposes. You can change this value. The dolly clock is just a clock where the numbers morph into each other. There's one point in the code where it says sync to the second strobe by repeatedly sleeping for about 1/10 of a second until time returns a different value. This is so that multiple instances of this clock program run in lockstep instead of being randomly staggered by up to a second, depending on when they were started and different other scheduling delays. And then in parentheses, it's the details like this that make the difference between a true hack and just another app. And it's comments like this that make the difference between code you want to read and code that's like horrible to read. And so this made me think about comments in general, and I ended up writing about this for the newsletter because I thought about the importance of comments to code, and I started wondering what was the first language that allowed you to write comments and put them in the code as you go along.
Sanskrit. Wasn't that one of the first?
Sanskrit.
Yeah, wasn't that one of the first written languages?
Yeah, right?
Well, I mean, languages are called languages because they develop from language. I mean, the written language turns into the coded language, right? So I think the habit of like taking notes in the margins definitely extended, like you said, into like punch cards. And then
Yeah.
at some point, when we started to move to code, people are like, oh, our comments can also be persistent if we do it right. So I would think it was, day 2. Like the first day was go to 10, and the second day was, hash mark or semicolon or whatever.
Yeah, you would think that, but way back in the day, storage was difficult, right? And a bunch of people bring this up in the comments. For instance, even though BASIC has the rem statement, which lets you put comments in line in your code, a lot of the time you take those out later because they take up precious code memory. It's almost certain that the first computers like ENIAC and things like that absolutely didn't have comments in their code. And so, back in the days when you were keying in machine code, you were doing the different opcodes in binary switches and hitting enter, right? Like there was definitely no way to put in comments there, and you'd have them just written down on a piece of paper going along with it. And I've definitely seen tape punch code that doesn't have comments.
Well, is it like Neo in the Matrix, and like people that are working on that can just look at those and read them? I mean, I would think if you're working in machine code, the comments are even more important.
Yeah, but you couldn't store them in the code. You had
Sure.
to store them as a separate book somewhere that was like, if you lose that book, you're totally screwed, right?
But what does storing them in the code really mean? I mean, you have to have a person take the code that the engineer wrote and turn it into something that the machine can run.
Well, no, that's what you got a compiler for.
Well, I'm thinking back at way back when, right? So you
That's
you
what you have
wouldn't
an assembler for.
right, but you wouldn't work on the machine if you were writing the software. You'd work on pen and paper, and you'd have someone else turn it into
Someone
like
else
a
actually
tape
typed
strip.
it in for you?
Yeah, you'd have like a person whose their job was to take the stuff that the engineers wrote and turn it into a tape strip that can be fed into the tape reader and loaded into the machine.
Anyway, I think there's a pretty compelling argument that Fortran, being one of the first compiled languages and definitely a language that has comments in it, is probably the first compiled language with comments. And Rob in the comments brings up Lisp, but Lisp is a little bit behind Fortran, not by much, but a little bit. David Enabuska brings up Soap, which was kind of a meta-programming language, and he says it has comments. I want to see somebody come up with an assembler that let you keep comments inline, because I know you can do that. And as I wrote in the article, the Apollo guidance computer had comments in it.
Can I go on another tangent? Because I have a question about...
Yeah, totally.
You mentioned in here APL comments are marked by this rune. What's the story with that rune? I've never seen that before.
What's the story with APL? Have you ever seen APL written out? There was an entire alphabet of these crazy symbols that all mean things. And APL was in some ways very high level and meant to do mathematical calculations. So there's like another rune that means run a regression of this variable on these variables and things like this. And you have to have a special keyboard that maps these funny runes to it. And one of them was the comment rune. And boy, I had a friend actually who took a job. We worked together in Washington, and then he took a job in New York where he had to learn APL for it was an actuarial firm that had a bunch of legacy code written in APL, and he had to learn it. And the first few months, he was just mind blown by it. Like everything else, you can learn it, but it's hieroglyphics.
Well, and stuff I hadn't thought of now. I'm over on the APL Wikipedia page, and we should probably put this in the show notes. But they have a section on hardware that talks about the IBM Selectrix typewriter balls that you had to have custom made so that you could actually type out the runes.
I would not be surprised. Yeah, I mean, these days you can just, display it on your screen. But back in the day, that was a bold and insane language choice.
All right, well, let's keep this party rolling, Elliot. I definitely have to talk about this article that Lewin wrote called "The Longest Ever Flight Was Over 64 Days in a Cessna 172."
Yikes.
So I've been on some long flights before. I think that flight when I went to China in 2019,
That's a long one.
I had a connection from Atlanta to Shanghai, which was something like 16 hours.
That's a long flight.
Yeah.
That's more than you want to be on.
Now, this was 64 days, 22 hours, and 19 minutes. So that would be like my flight to Shanghai plus 6 hours and 64 days.
Exactly.
And two guys, no real bathroom, right? No kitchen, no sofa.
They had a bucket.
And we're talking about 1958. So December 1958 to February 1959. It's kind of incredible, but I do kind of think back to that time period. And in my mind, I think that people were trying to break records then.
Yeah, this was the heyday of, kind of the Guinness Book of World Records and the longest this and the biggest ball of yarn.
Yeah. And kind of, I think the heyday of like personal flight, like you being a pilot was more of a thing in this time period than it had ever been before because you had access to these small aircraft. And so, assumably these pilots were like, hey, how can we get someone to pay for this? And one of the slot machine technicians was an amateur pilot, and he talked the owner of the casino into ponying up $100,000 for this attempt. And it was advertising budget because like the airplane on the side of it has, Hacienda Las Vegas, the name of the casino, painted on the side of it. $100,000 in 1958 dollars is $949,000 in 2021 dollars.
Yikes.
Yeah, so it's significant outlay, but if you think about that, I think of newsreels, and this definitely would be after the newsreel period, at least after the newsreel heyday. But I would think that like this is a way to get into the news regularly if you have this plane that's going up there. The question is, how do you keep a Cessna flying for that long? Well, you give it a 95-gallon belly tank so that it has a lot more fuel, and then you have planned out refueling and resupply periods where you would have a truck driving to match the speed of the plane along a straightaway, and you would have a hose drop down to get the fuel into the tank. And then you could also lower a bucket down and have them put, your food and other things in there.
Sounds convenient to me. If you've ever sat in one of these small planes, like the good thing about a Cessna is that it can go really slowly. So you can do this like docking with a car thing. The bad thing about a Cessna is the motor makes the whole damn tin can vibrate. Yeah. And they get moved around by like the smallest breeze, which makes me I'm not flight phobic, but it definitely, when you were talking about that long transatlantic flight, that's a smooth flight.
Oh, yeah.
Flying around in a Cessna is like, if a bird farts, the plane wiggles. You don't want to be anywhere in that thing. And for 64 days, yikes.
Yeah, and in 4-hour shifts, and I can just like you wouldn't have a smartphone in YouTube, right? So like reading books, I guess.
Right.
And it's
just sure.
It's a long time, and then you have to think about what two guys locked in a small space without proper facilities begin to smell like.
Oh, if they had doors on the thing, if the thing was airtight, you'd have to worry about what they smell like. I think by the time day 20 is rolling around, the thing's leaking so much oil and who knows what else that everything smells like kerosene and who knows what. Like, I think the two smelly guys, you wouldn't even notice them at that point.
I guess. Well, you ruined my in-link because the thing you want to read if it is sealed up is The Smell of Space that Dan wrote in August of last year.
Yeah.
Talking about reports from astronauts about what the ISS and other, missions to space kind of smell like. So I think that's kind of interesting. Now, as far as ability to move around inside of a Cessna, they did take the co-pilot door off of the thing and put an accordion style door there so that they could then slide out a platform and you could just kind of like hang out on this platform outside of the airplane when you needed to. And there's a nice story in here about they had to like quickly pull that thing in when someone was out there bathing and brushing their teeth because they were having trouble keeping altitude in order to get over a ridge that they might have clipped on the way over. Perhaps the best part of the story for me is getting to the end and finding out what happened to this plane. I'm sure I've walked under this oblivious to it.
Yeah.
It's hanging above baggage claim at McCarran, the airport in Las Vegas. So if you've gone to claim your luggage, I think there's like two wings of baggage claim there. So I'm sure I've been to both of them, but you might have missed it that way. But otherwise, you've walked right underneath this plane and didn't know the awesome story that could be told. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or see something cool, please let us know. tips@hackaday.com. And until next time,
Keep on hacking.
mine's muffled because I have hand warmers on.
Totally misleading and a little bit disingenuous.
Next.
Oh, this one's totally useful. What was I even talking about? Ah, well, who cares? And laps.
Oh, marvelous. Are we wrapped? We're going to the next one. And